Now we're going to conduct a p-value method for testing hypotheses. For the second one we looked at, the upper tail test. This was the one that read the National Health Statistics Reports described a study in which a sample of 361-year-old baby boys were weighed. Their mean weight was 25.5 pounds, standard deviation weight of 5.3 pounds. A pediatrician claims that the mean weight of 1-year-old boys is greater than 25 pounds. Do the data provide convincing evidence that the pediatrician's claim is true? Test at 1% level of significance. The p-value way of doing this problem is going to have us hitting stat, go over to test, go down to t-test, and dive into t-test by hitting enter. Select stats. Now, the purported population mean under the null statement is 25, so type in 25. The sample mean is 25.5. The sample standard deviation is 5.3. The sample size was 360. And notice that this is an upper tail test because our alternative statement says the population mean weight of all 1-year-old baby boys is greater than 25 pounds. So we go over and select greater than. Go down to calculate, and here we go. The test has been conducted. Notice our test statistic, 1.7899, blah, blah, blah. That's what we computed in step 3 when we showed all 5 steps, the manual way of doing the problem. We're not really concerned about that. We look at the p-value. The p-value is 0.037, and 0.037, notice, is greater than 0.01, the level of significance alpha that we set when conducting this hypothesis test. Because our p-value is a little larger than 0.01, we cannot reject the null hypothesis. So therefore, the claim that the mean weight of all 1-year-old baby boys being greater than 25 pounds is not supported. And that was the same conclusion that we ascertained when doing the problem, the critical value method. So that concludes this upper tail test via the p-value method.